Our next presentation is titled Visual Sensing and Analytics for Construction and Infrastructure Management, and is sponsored by the Academic Committee. Emerging technologies are improving construction processes. The presentation will address future uses and benefits of these new tools. Representing the Academic Committee, please welcome from Carnegie Mellon University, Burcu Akinci.
Through this short presentation, I'd like to invite you to our implementation session this afternoon on visual sensing and analytics for construction and infrastructure management. Before I start my presentation, I'd like to ask a couple of questions. Would you rather manage your projects proactively or reactively? So the answer is obvious. We all want to manage our projects proactively. We all know the benefits that proactive management can bring. Then the question becomes, why aren't we managing our projects proactively all the time? Certainly, cost cannot be an issue, since proactive decision-making does not require additional costs. However, proactive management involves an important element that is sometimes challenging to attain. It requires complete, accurate, up-to-date visual situation awareness and assessment at any given point in time on a construction site. That's where the challenge occurs. And that's where the visual sensing and analytics tools provide us an opportunity. Visual sensing technologies, such as digital cameras and laser scanners, enable streamlining the collection and analysis of spatial data needed for proactive construction management. The need for visual sensing will grow larger with ever-increasing trends that we're seeing at our job sites towards design with complex 3D shapes, unprecedented need for faster construction, and increased usage of modularization and advanced construction methods. Complete spatio-temporal situation awareness and assessment is no longer a luxury, but it's paramount for effective management of today's modern construction sites. It has been demonstrated that limited situation awareness has costly ramifications. For example, a prior CII study has documented that the costly impacts of defects not being detected on time during construction ranging from 8% to 20% of construction costs. In the top picture, you see an example of such a situation. What you're seeing is a color-coded map showing the spatial deviations captured during laser scanning superimposed to an as-designed model. The red colors indicate more significant deviations, and the blue and green colors indicate smaller deviations. As you can see in this figure, the column that was installed in the front is all red, indicating that its location is different from what is expected in the design. What is problematic in this figure is that not only that column is red, but also the beam on top of that column is also red, indicating that the contractor did not realize this quality issue and kept on building on top of it. This is an example of a situation where a site was managed reactively due to limited situation awareness, resulting in unnecessary cost and time waste. Similarly, during operations and maintenance, not having accurate, up-to-date information about facilities creates waste. In a NIST study done in 2012, it was documented that facility owners waste $1.5 billion annually due to their workers staying idle looking for information. And on top of that, there's another $4.8 billion wasted for verifying the existing information. These wastes can be eliminated by having better situation awareness. Along with this, we're also seeing a significant increase in the utilization of virtual construction tools at our job sites. Utilization of operation-level detailed 4D simulation models, such as the one that you're seeing, is becoming a commonplace on our sites. There are many benefits of virtual construction models, such as identifying conflicts ahead of time and supporting communication and coordination amongst different team members. Hence, these models enable us to manage our projects in a much more proactive manner. However, there's a missing perspective in virtual construction, and that's the reality. Without complementing our virtual models with reality, it's impossible to get a complete situation awareness. When we consider reality, we're thinking about several different types of visual sensing technologies, such as digital cameras and laser scanners. Photos collected from digital cameras or smartphones constitute one of these visual sensing technologies. And over the last few years, the number of photos collected from job sites has exponentially grown. This creates an opportunity to analyze what's happening at the job site from multiple perspectives. Similarly, we're observing an ever-increasing usage of terrestrial scanners and 3D imaging equipment on our job sites. These systems can collect gigabytes of spatial data depicting existing conditions at a job site within a very short period of time. All of these technologies are commercially available, but there's still research that needs to be done on analyzing the collected data and generating accurate and actionable information that project managers can use when making decisions. Recently, we are also observing increased utilization of aerial robots equipped with cameras and laser scanners on construction sites, as we saw this morning. Nowadays, it's possible to specify a location and send a robot to a large construction site or an infrastructure system to collect spatial information in a short period of time. As you see in this video, the robot can fly around the site and collect images and point cloud data, creating an opportunity for us to analyze the data in real time. Some commercial technologies exist in this domain, as we have seen this morning and as well as yesterday. And based on the investments that we're observing, the availability of such technologies will likely grow. However, making these robots truly autonomous and generating useful information from the data that they're collecting to streamline decisions are still open research areas. Availability of all of these technologies create many opportunities for us. Through advanced analytics coupled with these technologies, we would be able to perform integrated as-built and as-planned analysis, active progress monitoring and quality control, virtual inspection, automated as-built model generation, and life cycle damage detection and deterioration modeling, amongst other things. With all of these, we would get closer to a more proactive project management. In the implementation session this afternoon, we'll jointly explore the role of visual sensing technologies and the opportunities that they bring for construction project management. Specifically, we will understand the current usage of visual sensing and analytics for construction and infrastructure management. We're going to gain insights on future technology trends. We're going to understand emerging technologies and how they might be used to improve construction processes. And we're going to hear ideas for future CII research into innovative technologies. We have a panel of 4 speakers, ranging from academia and industry, and working in both civil engineering and robotics domains. We're hoping to see you. We'll be talking about 3 different technologies: image-based, terrestrial scanning, and aerial robots, as well as implementation of these technologies in the current practice. We're hoping to see you at 1 p.m. and at 2:25 at Wellesley at the 3rd floor to continue this conversation of the exciting opportunities that visual sensing and analytics can bring to construction job sites. Thank you.